honestly, the other big advantage is I can work with microbiota without pigs. Animal studies are very expensive, especially since I'm working with pathogen, for example, Salmonella. So if I do a Salmonella trial, I have to go in level 2 animal facilities. It's very expensive. And if you want to test like 10 different things, you need lots of groups and it gets out of hands. Here with a microbiota, I can test interesting solutions or hypotheses first, select the one that have a feeling that would work better, and then move only these into the actual animal trial. So it saves me a lot of pigs, so it saves animal lives, so it's better as an ethic point of view, and it saves a lot of cost in the end also.
Okay, hello everybody. My name is Ruud Zijlstra. I'm at University of Alberta and I'm dedicated to bring some latest insights to the Swine podcast show Canada. I have with me today Dr. Alexandre Thibodeau, who is at the University of Montreal and a research chair in meat safety. Welcome.
Bonjour.
So today's topic, Dr. Thibodeau, is synthetic microbiota. Could you perhaps explain to our audience what is a synthetic microbiota?
Well, of course, a synthetic microbiota is a microbiota that you create in the lab. So you can create it from frozen bacteria, you could create it from lab strains, or you can create it by cherry picking some bacterial group that you like better in an actual pig. So that's definitely what it is.
Feed formulation software is stuck in the past. Most tools haven't evolved beyond basic least cost optimization. A Diet Forge changes that. It's an AI-powered platform with nonlinear ingredient modeling for enzymes and additives, cost per gain and maximum profit optimization, and real-time collaboration like Google Docs for nutrition. Every recommendation is grounded in world-class research, built for modern nutritionists who need more than legacy desktop software can deliver. Work seamlessly with your team and optimize the way modern operations demand. Try dietforge.ai free today. Feed formulation, finally modernized.
And how do you then actually go about creating such a synthetic microbiota? In other words, what are the tools, what is the infrastructure that you need to make that happen?
So for me, what I'm using is actually a bioreactor that I'm using. So I am extracting the microbiota out of the pigs by having a system where I have culture media and I put my favorite microbiota source in this culture media, and then I let it grow. And the bioreactor is very controlled. It has an atmospheric control, so that actually it's anaerobic like it would be in a pig colon. Also, it has a very defined culture media to make sure everything stays stable. And we also control pH and the flow of the culture media, what's going in, but we also get rid of the waste with a waste output. So this way I can take bacteria inside a pig and bring them into my lab. And of course, the temperature is also controlled, so I can adjust it to whatever I want.
Could you perhaps give any idea about the size of the bioreactor that you're
It's not too big. It's actually a 60 ml bioreactor that I have. So it's a glass. It's made in glass. So it looks like your average beaker in the lab. The one thing that is very interesting is I have 8 of them side by side. So I can do 8 different conditions if I want at the same time.
Are there particular, because in the pig microbiota changes, of course, when you go from the mouth via the small to the large intestine to the rectum, are there particular segments of the intestinal tract that you have targeted, creating a synthetic microbiota?
For now, I'm targeting colon because this is where there is a lot of fermentation. It's also a nesting site for one of the bacterial pathogen that I like, which is Salmonella. So it allows me to extract a normal microbiota from a pig, put it in the lab, and then add Salmonella in the lab. So it helps me bypass any kind of pig work that I need to do. I will require pig work eventually, but with this system, you can try to screen things or make hypotheses on what you see in the lab instead of going into live pigs.
Yeah. And then when you describe the microbiota that you can create from the colon, is it then particularly the microbiota that is there in the lumen of the gut? For example, there's of course also microbiota that is attached to the colonocytes. So do you capture everything, or do you particularly capture the ones that reside in the lumen?
So for now, it's mostly in the lumen because I don't have any structure for the microbiota to attach to. But currently, we're working with partners to have like a second reactor attached to the one reactor. And in this reactor, we would provide spaces for attachment. So we're still defining how to go there. There's different things that you can do. But then I'm going to have to go back into the pigs because right now what I have is more lumen content. But if I want to make sure I have everything, I would have to take lumen content, but also scrapings of the intestinal walls to make sure that I have also bacteria that are mostly attached in the system. And then I'm going to put the mucosal microbiota and the lumen microbiota into the same reactor, but with a chamber where it could attach. So we're going to try to see if it improves. In the literature, you can see that providing a surface for attachment is lowering the drift of the initial microbiota compared to the bioreactor microbiota. So it should help get better results.
Obviously, you've already done some experiments with this bioreactor. So if you would compare it to the pig, you transfer the microbiota from the pig into your bioreactor. How stable is the microbiota in your bioreactor? In other words, if you go over time, how many days can you keep it, or weeks, if you will, can you keep it?
Yeah, you can keep it indefinitely if you want, but at some point it's gonna drift. So what we do in the experiment, the university being the university, we have sometimes shift into electricity. And so I don't like having my microbiota study for 30 days, right? Because if something crash, you lose a whole month. So we try to do a very short experiment. So we see stabilization is a very big word, right? You can have small drift and it will always move. And do you tolerate these, or do you see, well, the main drift has happened and then I'm more in it's going to not be entirely 100% stable, but correct for making the study. So what we've seen is that after 3 days, the major problems or rearrangement of shift of the microbiota is done. And so for what we do is that we start the bioreactor for Monday, and then on Thursdays and Friday, we just do what we want to do with the bioreactor. And then we rinse and repeat.
And then what do you actually then need to bring into the bioreactor to feed the microbes? And what are you actually taking out of the bioreactor on anything on an ongoing basis? For example, the short-chain fatty acids that get produced, or how do you deal with that?
So there's no absorption. So that's the part that is biased, because in the intestinal lumen, you have absorption of these SCFA by the intestinal cells, which I don't. It's very hard to do. You need to work with osmosis system, and there is a very complex bioreactor that does that. Mine is more like a gentleman bioreactor, if I might say. So it's custom made. It's not something that we've bought. So we could implement this. As for what goes in, we've tried two different things. The one thing is an artificial digestion of pig feed. So we are collaborating with Yves Arcan, who works in AAFC here in Saint-Hyacinthe, No, not AFC, Agriculture Canada, and AFC in Saint-Hyacinthe. And then what they did is that they took like a pig meal and they digested it, and then I used that to feed the bioreactor. Problem was that there was a lot of big pieces left, and it was constantly clogging. So then we switched to what is used in the literature, which is a defined liquid culture media. It's not as good as I thought as the digester that we use, but it's more stable in between batch, and it's also a lot easier to use in the bioreactor. You could say just use bigger tubes, but if I use bigger tubes, I need to change pumps. I also need to increase the amount of culture media I use, and it's increasing cost. So I'm trying to keep it on the smaller size.
Is there any gas that is being produced that you need to take out of your bioreactor, like gas?
Oh yes, I forgot about that. We have an exhaust port that's just bubbling into water, so just to make sure that air do not flow back, and the system is under constant nitrogen pressure, so to make sure that if there's any leaks, oxygen do not get in.
So now you have this wonderful bioreactor, as you described. Actually, you have 8 of them. What is actually the purpose for them in your lab? Like, in other words, what are the things you're trying to study?
So the first thing we were with feed additive companies, and so we're trying to do something that was in line with that. And then, so we use different essential oils basically to see if we saw movement. We were seeing movement in pigs, but when you use these feed additives, is the bacteria changing or is the host changing and changing the bacteria? And we saw some effects, so we were very happy of that. It was the first time we were running the bioreactor. And then in another trial, what you use is there was another company that wanted to test for probiotics. So we wanted to see 2 things: is the probiotic was staying in the microbiota, and also there was different ways to administer the probiotic. To use it like one time to the pigs and then you let the pig grows, or to use it daily. And what we found out is that when we used a daily dose in the bioreactor, it was too rough on the microbiota. The microbiota was switching a lot compared to a one single dose. So we concluded that if we wanted to go in pig trial, we would do like one single dose or lower the dose that we were giving each day. So that was good results. And now we're trying to do different things. So you can test everything, right? You can test if you want. I'm also interested in stress. So I'm looking forward to see if we can put stress hormones on this microbiota to see what happens. Any host molecule you can put in. If you want to really know your favorite amino acids, for example, you can put it in the system without, when you're in a pig, you have to calculate how much will be available or something, and you're not sure if what exactly is absorbed or not. So in this system, you can testing more, without the host interfering. It's a good thing and a bad thing because the host is part of the interaction with the microbiota, but it gives different scientific perspectives.
Yeah, but a big advantage of your model seems to be you can basically focusing on what is happening with the microbiota itself, as opposed to when you do it in the pig, you always have the interaction between the microbes and the host. So is that what you see as a big advantage of your model?
Yes, it's a one big advantage, and honestly, the other big advantage is I can work with microbiota without pigs. Animal studies are very expensive, especially since I'm working with pathogen, for example, Salmonella. So if I do a Salmonella trial, I have to go in level 2 animal facilities. It's very expensive, and if you want to test like 10 different things, you need lots of groups and it gets out of hands. Here with a microbiota, I can test interesting solutions or hypotheses first, select the one that have a feeling that would work better, and then move only these into the actual animal trial. So it saves me a lot of pigs, so it saves animal lives, so it's better as an ethic point of view, and it saves a lot of cost in the end also.
Yeah, so in other words, you can use it as a very important screening tool.
Yes.
You can test many different feed additives, as you mentioned, and then pick the ones that seem interesting or promising and test those perhaps then in an animal model.
Exactly.
So with essential oils, are there any particular pathways that you can study as well? Why they may have such a reaction in your bioreactor, or anything interesting that you observed?
Yeah, we were very pleased to see, like, for example, we were not expecting this, but we saw lactobacillus increase with one of the essential oil. And the one thing that was also interesting is that we had prior data of a company that was testing that, and they were seeing the same thing in pigs. So we're very happy to see something doubling. So we also use in these, it's not in pig, it's in chickens, but we use a protease in chicken and one also in a chicken bioreactor microbiota, and we saw similar things happening. So we were very happy to see that there seems to be like at least a degree of correlation between real life and what is being done in the bioreactor. So the bioreactor is, how long has it been? It's been 4 years and it's been up and running. So have only one student at the time working on it. It's a bit clunky. It needs a lot of love. So I don't have as much output, and also looking forward to upgrade it. So I wish I can build this better to make it more relevant. And also there's a very big trend globally to alternate models to animals. So I wish to develop that to give this access to the scientific community.
Now, you raised the topic of Salmonella. So have you already done anything relative to Salmonella, like suppressing Salmonella or getting a microbiota that doesn't tolerate Salmonella? Like any interesting insights that you have?
Not yet. I can tell you that if I just putting, Salmonella lives nicely in this system. So that was very good. So we can, first step was to see if I have Salmonella-free pigs, can I incorporate Salmonella in the bioreactor? And it's working. So that's nice because I have a tool to study. If I compare that to my Campylobacter in my chickens, it was very hard to add Campylobacter into the microbiota, artificial chicken microbiota, but we got there with a lot of modification. And so in regards to Salmonella, we can put it in, tested a couple of probiotics that had an effect that lowered Salmonella counts. The one I talked about, so the two conditions were able to lower Salmonella, so that was encouraging. But so far, I haven't been able to select, let's say, for a non-permissive microbiota versus Salmonella. Not there yet.
So you picked Salmonella because it's an important disease in pigs and perhaps even in people? Is that why you started with Salmonella?
Yes, exactly. I'm working a lot in food safety, and so Salmonella is important in pigs because it's not a very big pathogen in terms of proportion. It's more viruses and E. coli right now that causing enteric problems, but it still does happen sometimes in piglets and more in growing finishing pigs. But it's also a food safety issue. So I really like this model because it doubles as a pig problematic and a human problematic.
And then potentially you could. Do you think there will be much difference between pig digesta from the colon and human digesta in the colon? So in other words, can your models that you have, can it serve for both species, or is it mostly on the pig side?
That's a very interesting question because you always try to do translational science. We're going to try it, but in the ileum, because we have another project funded with other partners that's going to focus more on, they want to make, they're interested more in digestion, so they want to make a human ileum. But we will start with pig ileum just to set up the parameters and then use a precious human ileum after that. So we'll be able to see how the two are comparing. It's not the same thing, unfortunately, but the main families are the same. So I haven't checked the function, gas production or local antibiotic production or proteomics of all that. So eventually we should do that and see how it compares to published human literature.
And then, of course, when it comes to pig production, we have some big challenges with small intestine health, like E. coli bacteria, etc. So do you see any future relative to your bioreactor to studying diseases that may occur immediately after weaning?
Oh, definitely. This is where we are aiming for. Weaning is also where most antibiotics are being used. And this is also a very critical step where producers loses a lot of money, lots of health, welfare issues, antibiotic resistance issues. So definitely it's the go-to. We will have to adapt the bioreactor. The problem is that ileum is not 100% without oxygen. There is still some dissolved oxygen, so I will have to use custom gas to make sure that everything is fine, but we're going to work on this model. So definitely also ileum, there's a lot of absorption going on, a lot of digestion still going on because of the bile in all the enzymes. So it's a very interesting site, and we have very poor information on the pig ileum. Lots of microbiota studies are more, feces or colon, but we don't have any upper gastrointestinal tract. So I'm looking forward to increased knowledge on that.
When you look a little bit into the future, what do you potentially see as some of the outcomes of your research that may be tied to pig production? And let's start there.
As you said in the introduction, maybe we can have a synthetic microbiota, a very complex microbiota that can be used as a super probiotics, for example. So if we can find something very defined that is working well, especially in piglets, and that you can use as at weaning, because at weaning there is a very big shift, right, between the different type of feed, and the animals are stressed and they stop eating. So there's a very big opportunity just to give them a microbiota that would stabilize them a bit more. And so if we can make something like that, we can find the perfect bioreactor microbiota, maybe we can use this. There's a lot of researchers that have tried that. There's very good product possible, but in industrial scale, it's still not available because we'd have to take that and multiply that and all of this. And eventually, you can even see if you can more focus on the byproducts of these bacteria and use this instead of the bacteria themselves. You can study pathogen interaction, let's say pathogenic E. coli within. Pathogenic E. coli, they kind of hide in the microbiota. Why do they hide? And can you, force things? You can try crazy things like type 6 secretion systems. You can try, CRISPR-Cas for blocking antibiotic-resistant dissemination. Lots of fun things to try.
Yeah, but then you would particularly target the time around weaning when there's major shifts happening in the intestinal microbiota.
Yeah, that would be the best.
Has anybody tried anything like this right at birth? Of course, at birth, there's colonization happening for the first time, we think, right, in the piglet. Would that be another potential target? Or you say, no, weaning is so critical, let's start there?
It depends on what the question. I mean, even if you work at weaning, you have to decide what you put into the bioreactor. So do you take pre-weaning piglets, sacrifice them, and use that as seeding, or do you use more like nursery pigs to get your materials? So the timing depends on what you want to have. So both are very relevant in my view.
Of course, you're a chair in meat safety, so could you perhaps elaborate a little bit more on the critical role that Salmonella plays relative to having a stable and safe food supply?
Oh, it's crucial. I mean, it's very important to have a food chain free of salmonella. It's important for the health of the pigs, but also for the consumers. It's also a branding. Nobody wants to be tied to a recall or something. Right now, there's no limit. I mean, in Canada, you can assume that meat is contaminated with foodborne pathogen. But if you can remove that out of the equation, it's giving you a very nice premium of a meat. It's just also something to be proud for the industry that we are in Canada, very good at producing pigs without salmonella. It's also a matter of proud and maybe a label that we can, see. We control salmonella. We, trust our meat. It's the best meat in the world. It is already is the best meat in the world being produced in pigs in Canada, but you can, have a premium on that. And it's also very important to make sure that if you do any intervention on farms and a new vaccine, a new ingredient, you don't want to be changing that situation. So even if you're trying a new ingredient, you have to check, well, if I introduce this new protein source, will I have more salmonella in the end? So will I destroy all these efforts that were made to reduce salmonella pressure in the food chain?
And then relative to your bioreactor, you hope then to end up with some practical solutions that would allow farmers to reduce salmonella.
Yeah, definitely. Definitely. I hope to get there eventually.
It's time for our famous three.
Well, thanks very much. Do you have any particular resource that our audience could potentially look at if they're interested in salmonella, if they're interested in your bioreactor? Is there a particular resource on the internet or anywhere else where they can look at to follow up a little bit?
Oh, yes, we can always follow up my linking page. This is where I posted all the things that's happening in the lab. You can also look at the publication. We have some also articles that we've written, but they are in French. They are more like synthesis of what happened and are destined to producers. They are right now in French. So you can look them up and then ask AI, for example, just to translate
Google Translate can help.
Google Translate, and then generally for like bioreactors, there's a lot of. I don't have the best system in the world. It's a good working system, so you can check out. There's people with crazy things with different gut stages attached to each other, and then absorption and all that. It's a very fascinating world to look into.
Perfect. Well, that concludes another episode of Swine, the podcast in Canada. Merci beaucoup, Dr. Alexandre Thibodeau. Nice to talk to you today.
Merci beaucoup.
Yep.